Welcome back everyone. Today we will talk about latent heat. Now let us introduce latent heat. Latent heat of a substance is the thermal energy that is taken in or given out to change the state of a substance without any change in temperature of the body. It has a SI unit of the joule and the symbol of capital L. There are two types of latent heat. Firstly, we have latent heat of fusion. It is the thermal energy that is taken in or given out for a substance to undergo a phase change from solid to liquid without any change in temperature of the body. We use the symbol capital LF. Next, we also have latent heat of vaporization. It is the thermal energy that is taken in or given out for a substance to undergo a phase change from liquid to gas without any change in temperature of the body. It has a symbol of capital LV. Now, let us introduce specific latent heat, which is the quantity of heat required needed to change the state of a unit mass of the substance at constant temperature. It has a unit of joules per kilogram and the symbol is small letter L. From the definition we can say that capital L is equivalent to the product of the mass of a substances and small letter L. Similarly, specific latent heat has two different types. Specific latent heat of fusion is the thermal energy taken in for a unit mass of a substance to undergo a phase change from a solid to liquid state without any change in temperature of the body. It has a symbol of small letter LF. Specific latent heat of vaporization is the thermal energy taken in for a unit mass of a substance to undergo a phase change from a liquid to a gaseous state without any change in temperature of the body. It has a symbol of small letter LV. We have three different experiments to find the specific latent heat of a substance that undergoes a change in phase. However, all three experiments relate to the same idea. That electrical energy is converted to thermal energy, which can be further broken down to VIT equals mL. A typical experiment that finds the specific latent heat of fusion can be shown here. Here, we can use the following equation. Notice that Q loss can occur, which is the amount of thermal energy lost to the surroundings as the ice melts. To minimize Q loss, we can either prevent any evaporation of water or add insulation to reduce heat loss. As for specific latent heat of vaporization, there are two different ways. Using an electrical heater and using a vacuum jacket. Here we use a vacuum jacket. The water undergoes a phase change from a liquid to a gas and reaches to the top of the jacket. At the top of the jacket, the water touches the cool surface of the jacket and condenses to form water droplets which goes through the tube and drip into the beaker. We use m as the mass of condensed water in the beaker and hence, use the following equation. Lastly, we have the electrical method as shown here. When the power supply heats the water will change phase from a liquid to a gas. The gas then escapes the beaker, resulting in a change in the reading of the balance beam. We use m as the mass of liquid lost to the surroundings, and we use the following equation below. That's all for today. Thank you for the effort to learn with me. Stay tuned for more interesting lessons. See you next time. Bye-bye.